All right, so the airplane is traveling at a speed of 700 miles per hour at a direction of 35 degrees west of north, and then the wind is blowing at 15 miles per hour at a direction of 70 degrees east of north. Find the resultant magnitude of the speed of the plane and find the direction of the plane. So a diagram for that would be like so. So the plane is traveling at 700 miles per hour. So this is 700 miles per hour. Okay, and then it's traveling at a direction 35 degrees west of north. So this is 35 degrees. Okay, and let me maybe try to write a little bit larger. It's 35 degrees. Okay, and then this wind, this is the vector for the wind, that's traveling at 15 miles per hour. Okay, 15 miles per hour. And the direction of this is 70 degrees east of north. So this is 70 degrees right there. Okay, so that's 70 degrees. So let's first solve for the resultant by using components. This is the component approach. Components, okay? We're going to use components. So if you sum the forces, assuming that x is positive, assuming that the right is positive, you sum the forces in the x direction, what you end up with is the x component of this force here is negative because it's traveling left. We're assuming that positive is right. So this is traveling to the left, so that's going to be negative 700, negative 700 cosine of 35. It's negative because this is traveling to the left. It's actually, I'm sorry, that's going to be sine. Forgive me. Negative 700 sine 35. It's sine because we want this component right there, and 35 is, this leg is opposite of the 35. So if you wanted to show all the work, you'd say sine 35 is equal to the opposite x over 700. You solve for x, you get 35 sine of 700. But don't forget the sine here, which is negative. All right, so then you need the x component of this. That's going to be positive because it's traveling to the right. All right, so the direction that we gave you for this was 70 degrees east of north. So this x component would be right there. That's the x component. So that would also be sine. It'd be positive 15 sine of 70. All right. So if you have questions, call in. I'm just going to keep going unless we get some telephone calls about this problem. We're not answering any questions besides what we're doing here. Let's finish. So now, I forgot my calculator. Oh, goodness, I forgot my calculator. Normally, I do not use a calculator, and I forgot that we were, oh boy, I forgot my calculator. Maybe we can have people call in who are watching. They have a calculator. They can help me out with what the sine of 35 and the sine of 70 is. But let's just keep going. Let's sum the forces in the y. That's assuming that up is positive. And if we want this vertical component here for this velocity here, that would be, it's going up. So you'd have to say 700, the sine, or that would be the cosine, because we want this vertical component here, and it's the adjacent leg. So we'd say cosine of 35. All right, now here, for the vertical component of that vector, again, it's going up, so we'd have to add. So we need this vertical component right here. The same thing as this vertical component here. This is the adjacent leg, so we'd use the cosine. It'd be positive because it's up. So we're going to say 15 cosine of 70. Oh, Lord, it's not. All right, 15 cosine of 70. All right, so we have the horizontal components here, and then we have the vertical components here. You have to be very careful of these signs. All right, so I need for people to call in. If any of my students are watching, I need you to call in with your calculator to help me figure out some of these, what the sine of 35 is and what the sine of 70 is. I forgot to bring my calculator. All right, is that someone who has a calculator? All right, thank you for calling, caller. How can we help you?
The negative 700 times sine 35.
Yeah, what is that?
Is negative 401.5.
Negative 401.5. All right, turn your television down, okay, and just talk to me through the telephone.
And 15 sine 70 is 14.1.
14.1?
Yes.
And then you add those together, what do you get?
415.59.
That was a negative 401. Negative 401.5 plus 14.1.
14.1. Negative 387.4.
387.4. And now let's do this. What's 700 times the cosine of 35?
700 cosine 35. 573.4.
573.4. And what is 15 times the cosine of 70?
15 times cosine 5.13.
5.13. All right, wonderful. So now what we're going to do is, and when you add those together, what do you get?
You get
578.53. 78, yeah, 0.53. All right, so now what we're going to do is we're going to take these components. This is a negative x component, so that means we're going to travel. We're going to travel to the left. Oh, go ahead, say that again.
To the left, right?
To the left, 387.4, and this means we're going to travel up 578.5, and the resultant is going to be right there. How are we going to get it?
The Pythagorean theorem.
All right, so you end up with 387.4, that's squared, plus 578.5, that squared is equal to c squared. So c is going to be equal to the square root of all that. 387.4 squared plus 578.5 squared. So can you put that in the calculator for me? I forgot my calculator. I don't know what I was rushing.
Square. Square root 696.
696. So that is the direction. That's in miles per hour. All right. Now the way we'd get the bearing is to get this angle right there. It would be west of north, and the way one of our students gets this angle here is they go about getting this angle here because these are alternate interior angles. So let's take the arctangent of 387.4 over 578. So we take arctangent of 387.4 over 578.5. Do you understand? You understand what I'm doing?
Yes.
Okay, so what do you end up with?
30 33.8.
So that's 33.8 degrees west of north. 33.8 degrees west of north. And you write it just like that. Okay, just like that. All right, so that's one technique. We're going to ask you to be able to solve that same problem in another way. It's a much easier way, a much quicker way.